In lesson 52, we're going to talk more about addition of rational expressions. Now remember, a rational expression is simply, you could maybe in more common terms, you could just say it's a fraction. So in the problem that's shown on the screen, you see that I have a over x plus b plus 2 over c. And I have three terms here. And really, in two of them, I have fractions. A over x is a fraction and 2 over c is a fraction. So we consider this to be rational expressions. So really, when we're talking about rational expressions, we're just dealing with fractions more or less. Now, what we said on this type of example, to do this, we lined it up vertically. I can think of b as b over 1. And what we need to do is we need to find a common denominator. And remember, another name for common denominator is least common multiple. So what are my denominators? I have an x, I have a 1, and I have a c. Well, what's the least common multiple of those? And the answer to that is simply xc. That would be the least common multiple, because remember, in multiples, if they're not, they don't have to be in all of them, and if they are, you take the larger exponent. And to finish this off, let's see, x times what is xc? Well, I'd have to multiply that by c, so multiply that by c. So I get ac in the top there. 1 times what is xc? Well, I'd have to multiply it by xc, so multiply the top by xc. And I get bxc. And finally, in the bottom, c times x, so I multiply the top by x, so I get 2x. And we're adding all these together, so my answer is going to be over the common denominator of xc, so I have ac plus bxc plus 2x. And I'm done because nothing in the numerator are like terms. And that's what we've done so far with addition of rational expressions. Now, let's look at example 1. Now, how is this one different than the example that we just went over? And to answer that, if you look closely, there's one major difference. In the second denominator, I have a combination of two terms. So this is what makes it different. Now, when I look at those two terms, when I look at the denominator of the one that I just underlined, that's a combination. That's just one number. You could think of that as just being one value, because whatever x is and whatever y is, when you add them together, you're going to get one value. So you could look at that as it's a combination of the two to get that one value. Maybe in more common terms, you could say that they're a married couple, because it's a combination of the two to give you this one common value. So these are connected. The x and the y are connected. So when we do this problem, we still write it vertically. You know, some of you are comfortable to writing it horizontally, and that's fine. But I'm going to write it vertically. And when we find the common denominator, or the least common multiple, let's see, I've got an x. Now, and here's something else there. I want to back up a little bit. You don't look at this as saying, hey, I got an x here and an x here, so I just have an x. No, that's not correct, because this x is connected to the y. They're a combination. So when I find my common denominator, yeah, I have an x here, but I also have that combination, or that connected value, or in other words, that couple of x plus y. And since it's one value, since it's a couple, since they're connected, I put that one value in parentheses. So my common denominator is x parentheses x plus y. Now to finish it off, I do what we just did before on the previous screen. So I have x times what is parentheses x plus y. Well, I need that x plus y. That's what I'm missing. So I got to take the top by that couple, or that combination of x plus y. So I have a parentheses x plus y, which in a little bit will simplify. Now on the bottom, I've got that couple, don't I? What else am I missing? Well, I need to multiply that by x. So I multiply the top by x. So I have bx. Now to finish it off, I have my common denominator. And then I have a parentheses x plus y, which in a little bit will simplify, plus the bx. Now just to make sure that I don't have any like terms up there, I need to really kind of mentally check or actually write it out and do this distributive property right there. So I have a times x is ax plus ay plus bx over x parentheses x plus y. And even in the bottom you could distribute that. For right now we're not going to. You could leave your answer like this, and the only reason I did this is just to make sure I don't have any like terms above, because remember, when you have parentheses it's not quite simplified. But for the time being, it would be okay to have the answer in what I have the rectangle around it. You could have this answer. You could even have this answer, ax plus ay plus bx, and then distribute the bottom over here and have x squared plus xy. That would be okay. So this would be fine, this would be fine. Probably for right now, you probably would see this answer most commonly written. Okay, let's take a look at example 2. Now in example 2, same type of situation. We're adding rational expressions. So I have that married couple right there. And I'm going to put that in a different color just to emphasize what we have. And then I have a b. And then really, remember, that's just c over 1. So I'm going to write it vertically because I'm just more comfortable with that. So you have 5b plus c over a plus b. I have the x over b. And I have the c over 1. So now I need to carefully find my least common multiple. Alright, I have the married couple of a plus b. So I put that in parentheses in each of them. And I also have a b right here. And then I have a 1, but anything times 1 is just itself. So that really doesn't have any value right here. So my common denominator is b parentheses a plus b. And notice that I wrote b before the parentheses just because it's a little bit more familiar. Now let's finish this off. So I have a plus b, right, times what gives me what I have on the right. Well, I need a b. Now this is something else that's new. Am I just simply going to do this? If I just take the top times the raised dot b, what am I multiplying by b? Well, I'd only be multiplying c by b. That's not what we need to do, because I need to take b times this value. Alright, so I'm going to do that, so I have b times that value of 5b plus c. Now b times what? Well, I need the a plus b, and I need the a plus b, that married couple. So I need it in parentheses, like that. And finally, in the bottom one, I need everything. So I need to multiply that c by, and it's okay if I just write b and then a plus b. So I have cb or bc parentheses a plus b. So really this topic has a lot to do with use of parentheses and using parentheses to show that you have a connected pair. Now to finish it out, I have my common denominator, and then I have b parentheses 5b plus c. I'm probably going to run out of room here. Minus, I'm going to have to squeeze it in up here, x parentheses a plus b plus cb parentheses a plus b. And it's a little messy, sorry about that. So you can leave your answer like this for the time being. Even if I did distribute in the top, I would not have any like terms. If you decided to distribute, you know, that's okay. It's the same answer. Alright, so just to read that again, I have b parentheses 5b plus c minus x parentheses a plus b plus cb parentheses a plus b. All right, last example, and I'll make this one a little neater. I don't have any married couples down in the bottom, so I don't need to worry about that. But I'll probably have to worry about that in the numerators when I get the new numerators. So I have x over y, I have b over 1, and I have c plus d over m. Now what's my common denominator or least common multiple? Well, it's my or ym. I'll just write down my. Okay, let's find the numerators now. Let's see, y times what is my? I need an m, so I multiply that by m. It simply gives me xm, right? 1 times what is my? Well, I need my. So I multiply the top by my. Gives me bmy.